Welcome everyone. Welcome to today's session. And today we are going to discuss one of the topic, which is oscillators. Right now, the beginning of the oscillator is also the part of the JAM syllabus as well, especially Bronson condition and as well as the RC oscillator system. The JAM has also asked the question one or two times from this topic. But this topic is extremely important for GATE examination, BARC examination, and CSIR net examination. TIFR also asked this question in part C and part B of the syllabus, and just no more or less, I have never seen the question from this topic. So let's begin by studying this topic. Now, oscillators. So many times in electronics, we need sine waves, we need square waves, we need triangular waves. Now, in your lab, you might have seen that you use CRO, cathode rays oscilloscope, or other electronic devices which you use to basically compare your signal with the given frequency. So whenever you have to generate a sine wave or a square wave, you use oscillators. And our mobile phone produces these waves because, for example, our mobile phone is emitting some radiations, some signals deliberately. So when you dial someone, your phone emits a radiations. So those radiations are sine wave, and who produces them? Oscillators. Okay. So oscillators are very important part of our electronic circuitry, and in our syllabus, a very basics of oscillators are there in the syllabus. So what is the task of an oscillator? So let's take an example. So the very briefly, if I say the task of the oscillator is to convert DC signal into an AC output, sine wave, cosine wave, triangular wave, whatever. So you have a constant voltage. For example, your mobile phone battery is a DC battery. So this oscillator will take the DC battery and then it will convert into AC signals. So that is a work of oscillator. Okay. So all this technology, 5 gigahertz technology and 5G, 4G, what you listen to it is all because of the better and better oscillators you can make. So in an electronics, the more better oscillators you can make, the better will be the performance of your device. Right. Okay. So the frequency can be a very large range. It can emit from a hertz, few hertz, for example, audio frequency, to a gigahertz, for example, internet frequency. Okay? So frequency range is very large because the filter technology or oscillator technology has been developed so much. Okay? A very brief idea is that how the oscillator is made is very simple. You need two things. Number one, you need an amplifier. And this time you will have a positive feedback in an amplifier. So whenever you use amplifier, op-amp, in an integrator, differentiator, right? Different, you can say applications, you use a negative feedback. So what is negative positive feedback? We talked about it in the previous classes. You take some part of the output, and give it to input. Now there are two ways to give it. So either you can give it to the negative terminal or you can give it to the positive terminal, which will decide is it a positive feedback or a negative feedback. Or in more simple words, you can say that the feedback is increasing the gain or decreasing the gain. That is also one way of looking at it. So in order to build amplifiers, you need to have a positive feedback. So you will give your output to the positive side of the op-amp. Okay. Okay. So let me explain this circuitry and what is required. So number one thing we have is an amplifier. So in order, if someone asks me to very simplifying say that what is amplifier? Amplifier is something which increase the voltage. It has some gain. So it has some gain A. So for example, if I am giving V input, then my V output will be gain multiplied by V input. So basically what my amplifier did is ki multiplied the input voltage. So let's say the gain is 10. So the output voltage will be 10 times input voltage. So let's say this is 2 and the gain is 10, then this will be 20. So let's say gain is 100, then this will be 200. If the gain is 1000, then the output will be 2000. So amplifiers have some gain. And what does this gain do? Gain basically amplifies the voltage. So output is gain multiplied by input. So that is what I have written. Output voltage is gain multiplied by input voltage. Okay. So till this point is an open. Now I need some feedback. So this is my feedback circuit. So what is feedback? Again, let me describe feedback. So feedback is I'm taking some part of output and giving back to input. Okay? Basically, I'm not attaching this wire. So giving back to input. Now, how much part I'm taking? So I'm again and again saying I'm taking some part of output and giving back to input. So how much part I'm taking? So let's say output is 20 volt. So out of this 20 volt, how much voltage I'm giving back? So is it 10? Is it 20? Is it entirely 20 or 10 or 5 or 4? How much? So that is given by beta. So beta is a feedback constant, or you can say it decides that how much feedback you are giving back. So the voltage at this point, basically the feedback voltage which you are giving back. So feedback voltage which you are giving back to the input is beta times V output. So beta times V output. So beta decides how much fraction of output you are giving back. Okay. And that's all. And then you know that what is V output? V output is A into V input, right? As you can see here. So then you put it here. So finally, the feedback voltage, how much is the feedback? Feedback voltage is A into beta into V. Or you can, either you can write it as beta V output, or you can write it as A beta V in. So either you can write it in terms of output voltage or input voltage. So the two things are happening here. Number one, the action of a amplifier. Okay, action. No, if you are using a negative feedback, Agitar, in that case your circuits are different. Then we calculated the gains in the negative feedback circuits, right? So we in a different circuits we calculated the gain. Okay, so we are in this case we are giving a positive. We are not giving the negative feedback in this case. Okay, so again let me come back to the idea. So two people are working in this circuit. Number one, op amp. So op amp का काम क्या है? Op amp का काम है कि इनपुट को गेन के साथ आउटपुट में कन्वर्ट कर दें. So output will be gain multiplied by input. And then the second person is feedback. Feedback का काम क्या है कि आउटपुट का कुछ फ्रैक्शन वापस देना है. So some part of the fraction should be given back to input. How much fraction? Beta. It means feedback voltage will be beta times V output. और अगर आप V output की वैल्यू पुट कर देंगे तो beta into A into V input. So this is your feedback voltage. So this is the amount of voltage you are giving back. ठीक है? This is known as a loop gain. A beta is known as a loop gain. Now why it is called as a loop gain? The loop gain is basically कि starting में आपने V input दिया and when it came back तो V input वापस नहीं आया. कितना वापस आया? A beta into V input. It means after completing an entire loop, when you are coming back, you are not getting V input, you are getting A beta into V. So the feedback which is coming back is not V input, it is A beta into V input. That is why A beta factor is known as a loop gain. It is known as a loop gain. Okay? So any doubt till this point? Anything you are not clear with, or what is the basic structure of oscillator is not clear? Yes. ठीक है, कोई डाउट हो तो कीप आस्किंग दैट in your comments, or you can even unmute yourself, no problem. ठीक है. Okay, so with this much said, now I have to be very careful about this A beta. ठीक है. I want my circuit to have a sustainable output. Sustainable output. ठीक है. So if A beta is less than 1, A beta is less than 1, so after every loop the voltage will keep on decreasing. So basically you are getting an oscillations but these are the kind of oscillations you are getting, and ultimately oscillations will die because a beta is less than 1. So for example, so let's say a beta is 0.9. Okay, 0.9. So you start with 10 volt, and then when you come back, you are left with this a 9 volt. Then you again come back, you are left with this 8.1. Right? Again, back. No. What is inside the feedback? We will talk about it. I have not taught you yet what is inside the feedback. So that is the entire chapter. How we make this feedback is a next part of it. Okay? So yes, there are resistors also, but yeah, there are other things as well. Okay. So now it means if my A beta loop gain is less than 1, then ultimately my oscillations will die out because every time my voltage keeps on decreasing. Okay. So I don't want this. On the other hand, if A beta is greater than 1, then my oscillations will just keep on increasing. So voltage will just keep on increasing. That is also I don't want. I want is a perfect oscillations like this, which do not increase, which do not decrease. That is why my A beta should be equals to 1. A beta should be equals to 1. That is the one of the condition for sustainable output. Because at the output, you want a wave which is sustainable. You don't want this kind of wave. You don't want this kind of wave. You want is a perfect wave which sustain itself for a very long amount of time. So A beta should be equals to 1. That is the first condition. Okay. The second condition is very good. The feedback voltage should be in phase with input voltage. So there should be no phase difference between feedback voltage and input voltage, because if there is a phase difference, okay. So for example, let's say this is 10 volt and this is also 10 volt, because A beta should be 1. But then there is a continuity. But let's say there is a phase difference. One is 10 and another is 10 in a different phase. Then they will cancel each other out and give you 0. So this voltage and this voltage should not cancel each other out. There should be no phase difference between them. Otherwise, when you are giving the feedback, then the feedback voltage and input voltage will sort of cancel each other out, or will not be in a smooth continuity and will not give you a perfect sustainable output. So in order to get a perfectly sustainable output in case of your oscillators, two conditions has to be satisfied. Number one, loop gain, which is A beta, should be equals to 1. And second, phase difference between input and feedback should be 0 degree. So these two conditions are written here in a very nicer way. And these two are known as, I don't know how to spell it, but Bork-Hessen or Bork-Hossen criteria. I don't know what is the correct pronunciation, but this is a criteria. So, and this is a question which also has been asked in IIT JAM. Very simple. So whenever someone asks you that, okay, forget about what filter I'm talking or what oscillator I'm talking about, any oscillator, what are the basic principles for any oscillator to work? So the basic principle for any oscillator to work, number one, loop gain is 1, A beta is 1, and the phase difference between feedback and input should be 0. If these two conditions are satisfied, you will get a sustainable output as shown. Yes, any doubt? Yes, now I'm giving you 2-3 minutes. Think about. Now what we have here, we have to decide what is this circuit. I said, okay, there is a feedback circuit, and the feedback circuit gives beta amount of voltage back. But how is it made? So the way you make it decides your oscillator. So there are different kinds of oscillator, and every oscillator has a different feedback circuit. So depending upon what feedback circuit you have, your oscillator will be different. Okay. So there are few oscillators, for example, AC oscillator, LC oscillator, crystal oscillator. ठीक है, इसको आप RC oscillator भी बोल सकते हैं, RC oscillator, relaxation oscillator, and Wien bridge oscillator. There are many names, many names. For us, there are two oscillators which are important. Number one is a RC oscillator, and number two is a Wien bridge oscillator. Okay, so these two are the important oscillators, and we need to study them. And both of them have a different feedback cycle. So what is different in them is a feedback cycle, right? So let's begin with the RC oscillator. So in an RC oscillator, you have a RC circuit in the feedback. So in an RC oscillator, in the feedback, you will have is a R and C, resistor and capacitor. So RC oscillators generate a stable sine wave. The frequency of those sine wave is less. For example, it is in the audio range. Okay. Now what happens is what is the requirement basically? If I want to produce an RC oscillator, what is my requirement? See, I know that overall phase difference should be zero. Overall phase difference should be zero. But if you look at it carefully, if I apply any voltage to the any voltage to the inverting terminal, then automatically 180 degree ka phase difference will come. Because what does non-inverting terminal and inverting terminal do? Inverting terminal 180 degree ka phase shift le aata hai. Basically negative sign it brings it. If you have studied op-amp in the previous classes when I took it, then you know in a inverting terminal what happens is if you are giving 10 volt here, then here you have is a minus 10. So 180 degree ka phase shift is already there because of the op-amp. Feedback tak to bhi aap pahunche hi nahi. You have not even started doing an analysis of feedback. Even before you give a feedback, there is a 180 degree phase difference. But the condition says that there should be no phase difference. It means that your feedback should also give 180 degree phase shift, so that 180 and 180 cancels each other out, right? So that is why your feedback circuit should also give 180 degree feedback. So 180 degree phase is given by op-amp, 180 is given by feedback, so both cancels out. Hence there is no phase difference between feedback and input. Input and feedback has no phase difference with each other. Therefore feedback circuit must give 180 degree phase difference, so that it can cancel with the 180 degree phase difference given by the op-amp. Okay, so that is the scenario. So whatever circuit we make, our circuit should have 180 degree phase difference. Okay, now I will teach you how to find the phase difference in any RC circuit. Although I have already taught this in a lectures on gains and phase differences, which are available on YouTube as well, and I gave you that lecture few days ago. So but I will, very slight part of it I will repeat. Okay, so this is my circuit. So my circuit has two things, one is capacitor, one is resistor. This is high pass. High pass filter means it will allow large frequencies and it will block low frequencies. High pass means it allows to pass the high frequencies. Why? That is given in the lecture which I have given you on a YouTube. If you want to understand why this is a high pass filter, then that is covered there. But this is a high pass. So basically you are giving input and you are getting some out. Okay. Again, I want to know the relation. What is the relation between output voltage and input? I want to know that relation. In order to understand that, I need to know how the voltages work in our resistance and in capacity. Basically, now we are in a AC signals. We are no longer can be entitled ourselves into DC, because now our voltages can change with time. So in AC signals, there is something known as a phase diagram, which is very important, and I will just give you a basic idea of that. What is a basic idea? So in AC signals, whenever you are in AC signals, two things are important: the magnitude of the voltages, okay, and also the phase of the voltage. So okay, let's be very clear. So if you have a resistor, then the resistance is R. Okay, or you can say the voltage on a resistor is VR. So let's say you have a three people connected with each other: capacitor, resistor, and inductor. Okay? And you are giving an AC signal. You gave AC signal. Then okay, perfectly fine. Then the voltage on this resistor is VR. Voltage on this resistor capacitor is VC, and voltage on inductor is VL. You cannot say the total voltage is VC plus VR plus V. That will be wrong. That will be wrong. That is the beauty of AC signals, that you cannot say that okay, इन तीनों का voltage मिला दो, add कर दो, that will be the total. No. You have to add basically by keeping in mind about the phase differences, or you can say vector addition करना पड़ेगा. You have to do a vector addition. ठीक है, तो that is very good. हाँ, एक बात I can say, इसकी तीनों में current से, all three have the same current. ठीक है, तो what is the voltage in resistor? Voltage in resistor is current into R, IR. What is the voltage in capacitance? Is it IC? No, it is I into XC. What is XC? ठीक है, फर्स्ट ऑफ ऑल करंट को कैपिटल आई लिखते हैं, अदरवाइज यू विल बी कंफ्यूज. इट्स नॉट आयोटा, इट इज करंट. आई इंटू एक्सी. नाउ व्हाट इज एक्सी? एक्सी इज द रेजिस्टेंस ऑफ द कैपेसिटर. हाउ मच resistance a capacitor gives, and the formula of xc is given by 1 by omega c. I hope that you know this much of basic AC signals. xc is given by 1 by omega c. ठीक है, and what is the voltage in inductor? VL. VL is I into XL. Now what is XL? XL is a resistance given by the inductor. Resistance given by the inductor. And how do you define XL? XL is defined as omega L. Right? J part I am bringing. So right now I am talking about the magnitudes. So these are the three magnitudes of the voltages. Okay. Now there is a very interesting part. So can I say the total voltage is IR plus IXC plus IXL? No, that is I cannot say. That is I cannot say. Okay. So why? Because there is a phase differences. For example, if the voltage in resistor is 0 degree, then the inductor voltage will lead by 90 degree. 90 degree basically means if this is a sine wave, then this will be a cosine wave. This will be a cosine wave. Okay. So if the voltage in a resistor is sine, then the voltage in a capacitor will be cosine. Okay. Second part, voltage in inductor is cosine, then voltage in capacitor is minus cosine. So basically what is happening here is that voltages also have a phase difference between each other. So what is the phase difference in voltage of resistor and inductor? 90 degree. तो कितने का phase difference है resistor और inductor के बीच में? 90. इंडक्टर की वोल्टेज लीड करती है. यू कैन क्लियरली सी द वोल्टेज इन एन इंडक्टर लीड्स एंड इंडक्टर इन अ कैपेसिटर लैग्स. ठीक है, दैट इज व्हाई वी आल्सो पुट अ माइनस साइन समवेयर समटाइम. ठीक है, बट आई एम नॉट पुटिंग अ नेगेटिव साइन बिकॉज आई एम टॉकिंग अबाउट अ रेजिस्टेंस इन दिस केस. तो अब नेगेटिव लगाते हैं. तो बेसिकली द वोल्टेज इन अ कैपेसिटर लैग्स resistor by 90 degree, voltage in a inductor leads 90 degree. तो इसकी वोल्टेज 90 डिग्री आगे होगी, इसकी वोल्टेज 90 डिग्री पीछे होगी. किससे पीछे होंगी और किससे आगे होंगी? रेजिस्टर की वोल्टेज. तो रेजिस्टर की वोल्टेज के कंपैरिजन में इंडक्टर की वोल्टेज 90 डिग्री आगे होती है, और रेजिस्टर के कंपैरिजन में कैपेसिटर की वोल्टेज 90 डिग्री पीछे होती है. दैट इज वाई ये जे साइन लगाया जाता है. जे का इलेक्ट्रॉनिक्स में मतलब है अयोटा. अयोटा दैट यू नो, अयोटा वाला अयोटा. ठीक है, बिकॉज ई की पावर अयोटा पाई बाय 2 को अयोटा लिखा जा सकता है यूजिंग डी मोइवर्स थ्योरम. तो जब जब फेज डिफरेंस पाई बाय 2 होगा, डी मोइवर्स थ्योरम के अकॉर्डिंग अयोटा निकलकर बाहर आता है. पोलर रिप्रेजेंटेशन में अयोटा निकलकर बाहर. दैट इज व्हाई अयोटा इज बीइंग मल्टीप्लाइड. ठीक है, अब इन तीनों का वेक्टर एडिशन करना पड़ता है इफ यू वांट टू नो द फाइनल वोल्टेज. लेकिन वो सब हम इसमें नहीं करेंगे बिकॉज वी आर नॉट स्टडिंग एसी चैप्टर एज सच. वी ओनली नीड टू नो द बेसिक्स. और वो बेसिक्स क्या है? वो बेसिक ये है कि एक पेज में ऐड करके एक बार बेसिक्स को हम रिकैप कर लेते हैं कि व्हाट आर द बेसिक्स ऑफ एसी वी शुड नो. So the basics that is very important. Let's say you have all the three people. Okay? So you have a resistor, you have is a capacitor, and you have is a inductor. Okay? And you give some voltage. So let's say I tell you the total current in the circuit is I. Then the voltage in this will be IR, voltage in this will be IXC, and voltage in this will be IXL. ठीक है? Current, capital I, capital I. ठीक है? But it does not mean the total voltage is IR plus IXC plus IXL. No, that is not true, because VR is in this direction, VL is in this direction, and VC is in this direction. I can simplify it. I can say, okay, let's write it as VR. Now VL or VC को minus करके I can write it as VL minus VC. And then these two vectors are perpendicular. So you know that if two vectors are perpendicular, what is the resultant? Under root of A square plus B square. Then you can say it is VR ka square plus VL minus VC ka square. Okay? That is what you can write. You cannot say V is equals to VR plus VL plus VC. That will be the wrong thing. It means inductor leads, inductor का voltage leads resistor का voltage कितने डिग्री से? 90 डिग्री से. इसीलिए if I am writing VR as VR, then VL should be written as J के साथ, and V should be written as minus J के साथ. Whatever is a voltage, आपको उसके साथ plus J या minus J लगाना पड़ेगा. प्लस J का मतलब है 90 डिग्री आगे, माइनस J का मतलब है 90 डिग्री पीछे. That is the entire analysis, and this we should know. ठीक है? तो अभी हम अपने क्वेश्चन पे वापस आते हैं. Let's come back to our problem. So this was my RC circuit. I give some input voltage and I want to know the output. Basically I want to know how much is a voltage on this resistor, क्योंकि जो भी voltage resistor पे होगा वही output voltage होगा. So what is my voltage on this output resistor? So do you all agree, believe, let me know in the chat box, do you all agree that this total input voltage is dividing into two people? One is a capacitor and one is a resistor. So my total input voltage, some part goes to capacitor and some part goes to resistor. Do you all agree with this? First of all, right? So some part will go to capacitor, some part will go to resistor. Now you should also believe me, or you should also agree with me कि voltage division का rule क्या होता है? What is a voltage division rule? कि अगर मैं second बंदे के ऊपर voltage निकालना चाहता हूँ, तो first of all I have to write total voltage, फिर second बंदे की resistance divided by first बंदे की resistance plus second बंदे की. This is a voltage division rule. So voltage division rule says कि if I want to find the voltage on the second person, then I have to write total voltage V, then the resistance of the second person divided by total resistance, which is R1 plus R2. I want to know the resistance on resistor. There are two people here, one is a capacitor and one is a resistor. I want to know the voltage on resistor. So first of all, I will write the total voltage. So my total voltage is V input. Then I will write the voltage of the resistor, resistance of the resistor. So resistance of the resistor कितना है? R है. R है. So here you can see R. Then R1 plus R2. Okay, R1 plus R2. इसकी resistance तो R है. R2. इसकी resistance को हम कैसे लिखेंगे? XC अकेला नहीं लिखेंगे. We will write minus J into XC. Because resistor के comparison में capacitor पीछे है. इसके लिए minus J लगाना is very important. So that is why you can see here R minus J into XC. So this is the use of a voltage division rule. So आपका जो output voltage है, basically output voltage means what is the voltage on resistor? That can be written as total voltage, which is V input, into इसके ऊपर resistance कितना है? इसके ऊपर resistance है R1 divided by total resistance. Total resistance होगा R minus JXC. Why minus JXC? क्योंकि resistor के comparison में capacitor पीछे है, इसलिए minus JXC. Is it clear? तो V output by input की रेशो आ गई. Is it clear how? कैसे आई, क्या आया, ये क्यों है? ये बड़ा जरूरी है, इसको याद नहीं करना कभी. Never memorize this concept should be clear. How did I derived it? So यही पूरी गेम है. This is the entire game of AC signals. जी, any doubt anyone, please let me know. but the thing was we wanted to know the phase difference कि ये RC circuit. So let me bring you back what we started. So what we started is कि ओवरऑल फेज डिफरेंस जीरो होना चाहिए, ओवरऑल फेज डिफरेंस शुड बी जीरो, बट 180 डिग्री का फेज डिफरेंस तो एम्पलीफायर से आ गया. इट मींस 180 डिग्री का फेज डिफरेंस आरसी सर्किट से भी आना चाहिए, और मुझे ये 180 डिग्री का फेज डिफरेंस आई नीड टू ब्रिंग. सो देन आई मेड द आरसी सर्किट, एंड नाउ आई वांट टू नो हाउ मच दिस आरसी सर्किट, इस आरसी सर्किट का फेज डिफरेंस कितना है, हाउ मच दिस फेज डिफरेंस कैन बी. सो मुझे एक कॉम्प्लेक्स नंबर मिल गया है. सो दिस इज अ कॉम्प्लेक्स नंबर. और जब भी कॉम्प्लेक्स नंबर का फेज डिफरेंस निकालना होता है, पहले तो कॉम्प्लेक्स नंबर को यू नीड टू राइट इट इन अ प्रॉपर वे. तो उसको प्रॉपर वे में लिखने के लिए व्हाट आई विल डू इज आई विल रेशनलाइज. सो हाउ डू आई रेशनलाइज? आई विल राइट आर प्लस जे सी से मल्टीप्लाई एंड आर प्लस जे एक्स सी से डिवाइड. जे इज अयोटा, तो जो काम अयोटा करता है वो उसको जे के टर्म्स में लिखते हैं, सो दैट यू डोंट कंफ्यूज विद करंट. ठीक है, तो दैट इज व्हाई वी राइट इट इन द टर्म्स ऑफ जे इन एंटायर इलेक्ट्रॉनिक्स. ओके, then you can rationalize in the denominator, so you get a square minus b square. So a square तो r है, और then you have to do jxc का whole square. आयोटा का स्क्वायर नेगेटिव होता है तो आयोटा का स्क्वायर नेगेटिव होता है, ठीक है, परफेक्ट है. ए स्क्वायर में तो यहाँ पे प्लस आएगा, इट शुड बी प्लस. चलिए, उससे कोई फर्क नहीं पड़ता. सो इट विल बी आर स्क्वायर प्लस एक्स सी का स्क्वायर, and in the numerator you have is r into r plus j into xc. Okay, let's bring it here and let me write it here. Okay, ये चीज तो कांस्टेंट है, दिस इज कांस्टेंट, दिस इज नॉट एनीथिंग ऐसा, दिस इज कांस्टेंट. नाउ दिस इज अ रियल पार्ट एंड दिस इज अ इमेजिनरी. ठीक है, दिस इज अ रियल पार्ट एंड दिस इज अ इमेजिनरी पार्ट. एंड हाउ डू यू फाइंड द फेज डिफरेंस? फेज डिफरेंस इज ऑलवेज tan phi equals to imaginary part by real part. I hope that you know what is this class 11th concept of complex numbers. What is an argument of a complex number? Argument of a complex number, tan phi is equals to imaginary part by real part. Imaginary part is what? xc. Real part is what? r. इसको हम क्यों इग्नोर कर रहे हैं? क्योंकि ये रियल के साथ भी मल्टीप्लाई हो रहा है और इमेजिनरी के साथ भी. So it is getting multiplied with both. So when you divide them, it will cancel. So tan phi is equals to xc by r. ठीक है, परफेक्ट. तो अगर किसी को नहीं पता तो यू कैन इवन थिंक लाइक दिस कि दिस इज इमेजिनरी एक्सिस, दिस इज रियल एक्सिस. और अगर मैं ये फाई की बात करूं तो दिस विल बी इमेजिनरी पार्ट एंड दिस विल बी रियल पार्ट, राइट? एंड tan phi is equals to imaginary part by real part. So the phase difference given by this RC circuit is tan inverse xc by r. ये बड़ा इंपॉर्टेंट फॉर्मूला है सर, दिस इज वेरी इंपॉर्टेंट. कहीं भी पूछा जा सकता है, किसी भी वे में पूछा जा सकता है कि इन एन आरसी सर्किट व्हाट इज द फेज डिफरेंस? फेज डिफरेंस इज गिवन बाय tan inverse xc by r. And the derivation is also extremely important because sometimes they can twist the circuit. Now let's talk about the two extreme cases. The extreme case is कि xc is very very small. अब xc small कब होगा? क्योंकि xc होता है 1 by omega c. If you want xc to be very small, frequency should be very large. So for very 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 large frequencies, xc will be very very small, and let's say it goes to 0. So if this goes to 0, then phase difference also becomes 0. So phase difference is 0. तो पहला पहला बाउंड्री है कि फेज डिफरेंस मिनिमम टू मिनिमम कितना होगा? 0. लेट्स टॉक अबाउट द सेकंड बाउंड्री. Okay, let's say xc is very very large. If you want xc to be very very large, then the frequency should be very very less. बहुत ही छोटी फ्रीक्वेंसी, छोटे से छोटी फ्रीक्वेंसी. तो if the frequency is very less, then xc is very large, which means ये चीज जो है वो इंफिनिटी पे चली जाएगी. दिस थिंग विल गो टू इंफिनिटी. इंफिनिटी मीन्स tan इंफिनिटी कब होता है? 90 डिग्री. इट मीन्स द फेज डिफरेंस विल बी 90 डिग्री. So we can always oscillate between the two phase difference. Either this circuit, so basically this circuit can give you phase difference between 0 to 90. But you need 180. If you remember what is our condition, 180 degree phase difference amplifier से आ गया, तो 180 degree phase difference मेरे RC circuit को देना है. So my RC circuit has to give 180-degree phase difference, but your RC circuit can only give the phase difference between 0 to 90. So that will not work. So what I have to do? Then ideal people says, okay, use two ideal, op amps, sorry, two RC circuits. RC circuit. So 90 plus 90 will give you 180. But that is also not achievable, because you see 90 is a limiting case. It is not that you can easily get 90. 90 is you have to be very, very small frequency. You have to be ideally go to 90 degree. It is not easy to go to 90 degree. Ideally you can go up to 90 degree. But आपको भी पता है कि in physics boundaries are boundaries. You cannot achieve your boundaries very easily. Boundaries आ रहे हैं ना, पेपर पेन में होती है कि 0 से 90 के बीच में होगा कुछ. 0 और 90 को अचीव करना इज डिफिकल्ट. तो दो आरसी सर्किट मिलकर भी, even if you combine two RC circuit, you cannot get 90 plus 90 180. Then okay, let's do 3. 3 is achievable, because if you do 3 RC circuits, 1, 2, 3, and each of them is giving you 60, 60, 60, then you can get 180. So what I do actually is I do not use one RC circuit, or I do not use two RC circuit, I use 3 RC circuits. And I design my circuit in such a way that tan inverse XC by R should give me how much value? 60 degree. I have to design. That is electronics work, because XC is in my hand. You see 1 by omega C. R is in my hand. So I have to choose my resistors in such a way. I have to choose my omega and capacitance in such a way that everyone is giving 60 degrees, so that combined they are giving 180 degrees. So my RC circuit giving 180, amplifier giving 180, both cancel each other out. Overall phase difference is 0, and I will get a sustainable output waveform. Okay? So the final circuit looks something like this. Okay? And this is your final circuit. Not very important, but you need to focus here. There are different ways to attach this line. Okay, don't think I can attach it in many ways. इस पार्ट को इग्नोर करके इस पार्ट पे फोकस किया जाए. So there are 3 RCs. ठीक है, everyone is giving how much phase difference? 60 degree. How do you calculate the phase difference? The formula is XC by R. What is XC? XC is 1 by omega C. ठीक है, that is a whole theory. Okay. So there is a lecture which I have taken on low pass filters and high pass filters. You should definitely watch that lecture, but I will be very quickly recapping that lecture, means in 1 or 2 minutes. So there are RC circuit is a very special circuit. Basically the feedback which we have applied is a very special circuit. It's a RC circuit, and RC circuit can have 2 categories: high pass and low pass. High pass means it will allow high frequencies to pass, and low pass means it will allow low frequencies to pass. So you have a cutoff frequency, and what is the formula for cutoff frequency? ये सब कहाँ से आया? That will be in that lecture. So cutoff frequency is given by 1 by 2 pi RC. Now what will high pass do? High pass will allow the frequencies which are greater than this. And what will low pass do? Low pass will allow the frequencies which are less than this. Okay? And the circuits are in their front of you. So if you attach capacitor here and resistor here, then it becomes a high pass. But if you do the reverse, if you apply resistor here and capacitor here, then it becomes a low pass. Now it might come to your mind why this is high pass and why this is low pass. With this question in your mind, watch my lecture. And then I have even shown you why this is high pass, this is low pass. But the formulas that you need in this mind, by looking at the circuit, first of all, you should be able to know that, okay, which one is high pass, which one is low pass. The second, what is the formula for a cutoff frequency? So the formula for a cutoff frequency is 1 by 2 pi RC. Okay? So this is a question. And by looking at the circuit, so which part is a feedback part? Obviously, this part is a feedback part. Okay? Positive side में कौन सा feedback लगा है? Obviously this. Now by looking at it, you tell me, is it high pass, low pass? Very quick. You can look at the circuits. Which one is it? First category, second category. It's a high pass, obviously. Okay. So it's a high pass. And then what is the cutoff frequency? Cutoff frequency की बात करें तो 1 by 2 pi RC. व्हाट इज द वैल्यू ऑफ आर? आर कौन सा लेना है जो फीडबैक में है, तो आर कौन सा लेंगे 1 किलो, 1 किलो मीन्स 10⁻³ और सी कौन सा लेंगे 1 माइक्रोफेरेड विच इज 10⁻⁻6। इसको सॉल्व करेंगे तो आंसर विल बी 1। ठीक है, ओमेगा पूछा है तो 2 पाई जो है ऑब्जॉर्ब हो जाएगा। ठीक है, तो आंसर नंबर ए विल बी करेक्ट। तो इसमें कुछ इतना नहीं है, आरसी सर्किट के अंदर अभी तक बहुत ज्यादा कुछ फिल्टर्स में से क्वेश्चन आया है। सो आरसी सर्किट, आरसी ऑसिलेटर के अंदर इंपॉर्टेंट क्या है? सबसे पहले हमने इस लेक्चर में क्या किया, सबसे पहले जो क्वेश्चन कहां से बनेगा, फर्स्ट क्वेश्चन विल बी फ्रॉम ब्रॉक्सन कंडीशन। सीधा पूछ लेगा कि ओके एमएसक्यू में दे कैन आस्क, जैम के अंदर एमएसक्यू में ब्रॉक्सन कंडीशन आ भी चुका है, गेट में भी आ सकता है और सीएसआर नेट में पार्ट बी में कुछ वो सीधा क्वेश्चन पूछ। ओके, सो ब्रॉक्सन कंडीशन क्यों होती है, कैसे होती है, दैट वी शुड। सेकंड, आरसी से तो अभी हमने डिफाइन कर दिया कि ऑसिलेटर्स के अंदर क्या होता है, पॉजिटिव फीडबैक होता है। पॉजिटिव फीडबैक होता है तो ओके 180 डिग्री का फीडबैक जो है वो एम्पलीफायर से आता है। 180 डिग्री का जो फेज डिफरेंस है दैट शुड कम फ्रॉम द फीडबैक सर्किट। अब डिफरेंट डिफरेंट फीडबैक सर्किट्स आर पॉसिबल। पहला फीडबैक सर्किट विच वी स्टार्टेड टू स्टडी इज आरसी सर्किट। आरसी सर्किट के अंदर हाई पास फिल्टर्स होते हैं, लो पास फिल्टर होते हैं। जैसे ही आप आरसी सर्किट में एंटर करेंगे, द मोमेंट यू एंटर इनटू आरसी सर्किट, the question will not be from the filter from the oscillator part. The question will be coming from the filters part कि ये हाई पास फिल्टर है, लो पास फिल्टर है, कट ऑफ फ्रीक्वेंसी क्या है, ये दिस काइंड ऑफ क्वेश्चंस विल बी देयर एंड मेनी डिफिकल्ट काइंड ऑफ क्वेश्चंस आई हैव सॉल्व्ड इन दैट लेक्चर आल्सो। ठीक है, सो दिस वाज अबाउट आरसी। अब ऑसिलेटर के टर्म्स में जो मोर इंपॉर्टेंट है वो है व्हीन ब्रिज ऑसिलेटर। ठीक है, इसको नाउ वी विल डू टुमारो एंड इसके ऊपर पूरे में पूरी बात करेंगे कि व्हाट इज व्हीन ब्रिज ऑसिलेटर, इसमें क्या क्या याद रखने वाली चीजें हैं, क्या क्या समझने वाली चीजें हैं, वो ज्यादा इंपॉर्टेंट। इवन इफ यू सी लास्ट एक, आई थिंक 1 साल छोड़ के पहले सीएसआई नेट में क्वेश्चन केम। ठीक है, देन यू कैन क्लियरली सी द क्वेश्चन इन योर गेट ऑल्सो। तो क्वेश्चन इज कमिंग फ्रॉम व्हीन ब्रिज ऑसिलेटर, मोर इंपॉर्टेंट, वेरी सिंपल टू अंडरस्टैंड वंस यू नो दिस। बट आफ्टर व्हीन ब्रिज वी विल गो फॉर वन थिंग विच इज वाइब्रेटर्स। ठीक है, मल्टी वाइब्रेटर्स, सो दैट विल बी अ वेरी स्मॉल पार्ट, तो उसको वी विल ब्रिंग इन टुमारो। सो एनी क्वेश्चन टिल नाउ, बट आई विल सजेस्ट यू 2 लेक्चर्स हियर। वन इज एसी सिग्नल्स लेक्चर, आरएलसी सर्किट्स के ऊपर बहुत अच्छा लेक्चर एक अवेलेबल है विच इज अबाउट रेजिस्टर, इंडक्टर, कैपेसिटर। पूरा एसी सिग्नल आपको समझ आ जाएगा कि एसी काम कैसे करता है, एसी डीसी से अलग कैसे, टेक्निकली क्वेश्चन कैसे सॉल्व किए जाते हैं। जैम के लिए मोस्ट इंपॉर्टेंट लेक्चर, जैम में हर साल उसके ऊपर क्वेश्चन आ ही रहा है। सेकेंड लेक्चर विच इज इंपॉर्टेंट इज अ filters lecture which is taken again on the YouTube is available। वो थोड़ा छोटा सा लेक्चर है और ऑलमोस्ट जो मैंने अभी पढ़ाया वो उसमें कवर्ड है। ठीक है, so these 2 lectures are recommended before tomorrow's class। ठीक है, everything till now whatever I have taught is important for jam, after this nothing is important। ठीक है, so whatever I will teach tomorrow is not for jam students, it is only for gate and edge। ठीक है, ठीक है, नो नो विन, इवन विन ब्रिज यू कैन लीव। ठीक है, जैम में आई डोंट सी विन ब्रिज ब्रेक, कर लोगे तो अच्छी बात है बट एज सच नो प्रॉब्लम इवन इफ यू लीव। ठीक है,